We have an application of maximum, minimum, or extremes. Take note, in an extremes, we usually have first derivative of your function and then equate it into 0. So we will be using this one for solving problems involving extremes or maxima, minima. We have our example 1. Water is flowing into a vertical cylindrical tank at the rate of 24 cubic feet per minute. If the radius of the tank is 4 feet, how fast is the surface rising? Now, to solve this problem, of course, we have to draw first the diagram. So we have here a cylindrical tank, a vertical cylindrical tank. So we will draw a vertical cylindrical tank. Okay, so this will be our vertical cylindrical tank. Water is flowing into a vertical cylindrical tank. So water is flowing at the rate of 24 cubic feet per minute. If the unit is cubic feet, then that is volume. And then we have here per minute, so that is per unit time. That is why we have our volume per unit time. That is dV over dt, which is equivalent to 24 cubic feet per minute. If the radius of the tank is 4 feet, so this is our radius, which is equivalent to r. So our r here is equivalent to 4 feet. How fast is the surface rising? That means if there is a water flowing inside the cylindrical tank, then its level, say for example, this is the level of water, so it is now rising. So if this one, we call it as our height, we designate the level of water as height, h, then how fast is the surface rising? Then that will be our dh over dt. Height is changing or is increasing with respect to time. So this is now the unknown wherein we're going to find the value of dh over dt. So since given is the volume, then we have to compute the volume of this vertical cylindrical tank. Now the volume of this vertical cylindrical tank, V, that is equivalent to the area here times the height. So area is pi r squared times height. When r equals 4 feet, then when we substitute the value of r as 4, so when r is equivalent to 4 feet, then we will substitute the value of r as 4, so that the volume here is equivalent to pi times 4 squared, or 4 squared times height. So that is equivalent to 4 times 4, that is 16 pi times height. This time we apply the derivative. That means we have here the derivative of v with respect to time. That is equivalent to 16 pi times the derivative of height with respect to time. So we apply the derivative with respect to time. So we have here dv over dt, and then we have 16 pi over dh over dt. And then our dv, that is equivalent to 24 based on the given, which is equivalent to 16 pi and then dh over dt. This time, transpose 16 pi on the other side, that becomes 24 over 16 pi, which is then equivalent to dh over dt. 24 over 16 pi, that is equivalent to, using your calculator, that is 0.477. And then take note, this is dh over dt. Our height here, we use cubic feet as volume, therefore height is in terms of feet. And then per unit time in terms of, this is minutes, so feet per minute. That will be our dh over dt. t. So this will be our final answer. Another example is we have a rectangular plot of land that contains 1,500 square meter will be fenced and divided into two equal portions by an additional fence parallel to two sides. Find the dimensions of the land that require the the least amount of fencing. So rectangular plot of land. So we will draw first a rectangular plot of land. So we have here our rectangular plot of land. Okay. So this is now our rectangular plot of land. And then divided into two equal portions by an additional fence parallel to two sides. So we will divide it into two parts. We have this one. So this is a rectangle which is divided, the rectangular plot of land which is divided into two equal parts. And then the area is given, which is area equals 1,500 square meter. 1,500 square meter. Another one, okay, there's no other given data. So we will assume this one is our length, this one is our width. So this time we will make an equation. Area of a rectangle is equivalent to, take note, the area of a rectangle is equivalent to width times length, or length times width, based on this part, which is equivalent to width times length is equivalent to 1,500. Okay, so if this is equivalent to 1,500, then we can rewrite that width from this equation, that is equivalent to 1,500 over length. Or we can make use of length is equivalent to 1,500 over width. So you can use this one or you can use this one. Now we need to find another equation or create another equation to solve this problem. Now this is a rectangular plot of land, so we can make use of its perimeter, because here the question is find the dimensions of the land, so we're going to find length and width. So we can make use of perimeter. Okay, so perimeter P equals, to find the perimeter of a rectangle land, we need to add all the length. So this one is length, length, length. So that is 3 times L. And then W, width, and then width 2 plus 2 times the width. Okay. Now, this time, we will substitute, it's either length or width, this one. So I will substitute the value of width, which is 150 over L in my case. So we have here our P, which is equivalent to 3 times L plus 2 times width. Our width here is 150 over L. So 2 times 1,500 over L. It's not 150 but 1,500. So that this is equivalent to, our P is equivalent to 3L plus 3,000. You have here 3,000 L raised to negative 1. Why I'm raising up your L into negative 1? Because we will take the derivative of this one. So derivative of P with respect to L, so that is P prime, which is equivalent to, with respect to L, that is 3. Derivative of 3L with respect to L, that is 3. And then this one, the derivative, that is negative 3,000 L negative 2 as our exponent. And then in an extreme or maximum minimum, we equate this one into 0. So we have here 0, which is then equivalent to 3 minus 3,000 over L squared. And then I will transfer this one to the other side. That becomes 3,000 over L squared is equivalent to 3. By cross multiplication, we have here 3,000 divided by 3, which is equivalent to L squared. Okay, this one multiplied by 3, so that becomes L squared 3, and then 3 transfer on the other side. This will be your denominator for 3,000. So that when we answer this one, that is 3,000 divided by 3, that is 1,000, which is equivalent to L squared. And then the square root of 1,000, that is equivalent to 10 is square root of 10. So you can make use of your calculator to find the square root of 1,000. So I'm writing here 10 is square root of 10 as 1,000. Okay. So I have now the value of L. Find the dimensions of L. I mean dimensions of the land. So if L equals 10 square root of 10, so I can make use of this one to find the value of my W, or the width. So our W is equivalent to 1,500 divided by L. Since L equals 10 square root of 10, we will substitute that value. That is 1,500 over 10 is square root of 10. So that is equivalent to, I will write it here. So 1,150 W equals 1,500 divided by 10. That is 150 over square root of 10. By rationalization, we will rationalize this one. That is the square root of 10 times square root of 10. So I will transfer first this one. Okay, sorry for this one. Let me erase. Okay, so I will transfer first my picture on this side. Okay, so we have square root of 10 over square root of 10. Our width now is equivalent to 150 divided by square root of 10 over square root of 10 equals 10. 150 over 10, that is 15, is square root of 10. So this will be our width. Now take note, our area is 1,500 square meter. Therefore, our unit now is in terms of meter. So our length, again, I will write our length here. I am rewriting the length, that is 10 square root of 10 meters. So these are now our final answer for this particular problem. Another example, we have, or this is our example 3, a cylindrical tin boiler open at the top has a copper bottom. If sheet copper is 5 times as expensive as tin per unit area, find the most economical proportion. So if we have this what we call as economical proportion, we're going to find the proportion of a certain let's say length or height or radius of that particular boiler. Okay, so this one, of course, when we solve this problem, again we will draw a diagram. So this is a cylindrical tin boiler open at the top. So cylindrical tin boiler, we will draw our cylindrical tin boiler. So assuming this is our cylindrical tin boiler, and then we have, let's say, this one. Okay, so assuming this is the lower part, has a copper bottom, so this one is made up of copper. Okay, this one is made up of a copper. And then if sheet copper is 5 times as expensive as tin per unit area, then we will have our solution. So this is copper. The bottom part is made up of a copper, which is 5 times the cost of the tin. This one is tin, made up of tin. And then this one is made up of copper. So this cylindrical tin boiler is made up of two kind of materials. We have here tin and then copper. Now we have to solve. For this case, we will make use of our equation. Okay, so we will solve first the area. So the area of this copper, I mean boiler, we have area. Area equals, we have here pi r squared, pi r squared, pi r squared times the cost of this copper. We will solve first the area of a copper. Take note, this is the area of a copper. That is pi r squared times its cost, which is equivalent to 5 times the cost, let's say k, cost of this material. And then we also have the area of this tin, the side part of our cylinder. The side part, which is, how do we find the area? That is plus area is equivalent to the circumference, which is equivalent to 2 pi r times height. Okay, 2 pi r times height, of course, times the cost. We will make use of k as the cost of our tin. So height, this one, take note, this one, cylinder. Okay, we have here our cylinder, this part, and then this part. Okay, we have this portion. Okay, so 2 phi r, that is the circumference times the height. Take note, this is height. Okay, and then remember, k is the cost of the material. If the material is tin, this is k, its cost is k. If the material is made up of copper, then that is 5 times the expensive, or 5 times the cost of our tin. Okay, so this time we will find the area with respect to r for this case. So with respect to r, dA over dr, which is equivalent to, for this case, 2r dr. Okay, so 2r dr over dr. So 2 times 5, that is 10k. This is the cost. So 10k. Why 10? Because this is 2. 2 times 5, that is 10k pi r. Okay, 10k pi r dr. dr over dr, that is 1. So I will no longer write dr over dr because that is equivalent to 1. Plus on this part. Now, if you have noticed, we have here r and h. R is made up of the radius. Okay, we have here our radius and then the height. So we have two unknown variable. So I will write first 2 pi k, 2 pi k. And then if this is r times h, that is the derivative of uv. So r times the derivative of h over with respect to r, plus h times the derivative of r with respect to r. So derivative of r with respect to r is equivalent to 1. So I will no longer write dr over dr. So this is now the case. And then, of course, we have dA over dr. Equate this one into 0 for extremes. So we will equate this one into 0. Then we have 10 pi 10 pi kr, which is plus 2 pi k. And then we have here our r dh over dr plus h. Okay, and then transpose this one on the other side. That becomes negative 10 pi k times r, which is equivalent to 2 pi k, and then we have here r dh over dt plus h. So we will just copy this one. So if you have noticed, we can cancel this part. We can cancel 10 pi k, 10 pi k, I mean 2 pi k. So what remains here is negative 10 divided by 2, that is negative 5r. So negative 5r, which is equivalent to r dh over dt plus h. So actually we will transfer this one on the other side, so that will be your denominator. So 10 divided by 2, that is negative 5, and then pi cancel, k cancel, so what remains here is r. And then this time transpose this one on the other side, that becomes negative 5r minus h all over r, that is equivalent to dh over dt. So we find dh over dt, and we have here our proportions of r and nh, but we do not have the exact value. So this time we will solve for the volume of this cylindrical tin boiler. So we will find the volume, that is V. Okay, we have V equals pi r squared times height. Okay, the volume of this total cylindrical tin boiler. Okay, we will compute the volume. So we will no longer use the cost, because we already find the cost here, or we already used cost in solving the area. This time we solve for the total volume of this whole cylinder. Okay, so we have okay, wait. So dv over dr, so we have here pi, and then again we have here the derivative of uv. So take note, radius times height, wherein we take the derivative of this one, pi times r squared times dh over dr. By the way, we make use of dr for this part, so we make use of, it's not dt, but it's dr. Sorry for that, dh over dr, because we take the derivative with respect to r, so it's not t but dr. Okay, so dh over dr plus r squared times the derivative of h, that is dh over dr, plus h times the derivative of r squared, that is h times the derivative of r squared, that is 2r dr over dr. Supposed to be 2r over dr, but dr over dr, that is equivalent to 1. So actually I need not to write dr over dr, so I will just present here dr over dr, which is equivalent to 1. And then in extremes, we equate this one into 0. We have pi, and then r squared dh over dr plus 2, that is HR. dr over dr, that is equivalent to 1. So actually, we can cancel pi because pi will transfer to the other side. That becomes 0 over 5. So what remains is this 1. So I will transfer 2HR on the other side. That becomes negative 2HR. Negative 2HR. That is equivalent to r squared dh over dt. Okay. But it's not dt. Again, it's dh over dr. So dh over dr. But then our dh over dr is equivalent to this value. So we will write that value. We have here 2hr, which is equivalent to r squared. Instead of writing dh over dr, we will make use of this one. That is negative 5r. So I will just separate here this one, that is negative 5r over r, negative 5r over r, that is negative 5. So we have here negative 5. Okay. And then negative h over r, negative h over r. So actually, that is our dh over dr. Okay. Negative 5 minus h over r. So negative 2 hr, that is equivalent to, when we multiply, that is negative 5 r square, and then this one we cancel r square and then r, so what remains here is negative rh or hr. Okay, when we multiply r times h, we cancel r, so r times h, that is hr, and then we have here, we will combine hr, so that is equivalent to negative 2 hr, negative hr transfer to the other side, that becomes positive. So what remains here? Negative 2 plus 1, that is negative 1. So negative hr equals negative 5 r square. So for this case, negative negative cancel, so r transfer to the other side. So what remains here from this equation? So we have here h, which is equivalent to r transferred to the other side, that becomes 5r. We cancel r, so we still have 1r here, so times 5, that is 5r. That means the height is equal to 5 times the dimension of radius. This is now our final answer. Height is equivalent to 5 times the radius. That is the most economical proportion.